Back. We are going to be looking at the last math that we need to do for the chapter, which is called changing concentrations of a solution. So imagine that you already have a solution made. There's a stock solution that already exists, and you need to alter that in some way in order to make the solution that you want. There are two ways to change the concentration of a solution. You can either adjust the volume of the solution or the amount of solute that's in the solution. So one of the most common things we do in chemistry is called a serial dilution. So we're going to dilute the maybe concentrated acid or concentrated stock solution that we have in the cupboard. We're going to dilute that down to the amount that we need for a particular lab experiment. So you want to decrease the molarity or decrease the concentration, and that's because the solution is too concentrated. The easiest way to do that is to add solvent to it. So imagine that you had, again, back to our Kool-Aid or our lemonade example, you had some lemonade and it was too concentrated. That's a really easy fix, right? You just take some water and you pour it in there, and now you've diluted it. You have it the proper concentration for your taste. The other thing you can do, and this is a little bit more difficult, is you can try to increase the molarity. So if the solution is too dilute, now with Kool-Aid or lemonade, that's not too difficult to do. You just add some more solute to it, right? That's this last one down here. You could just take a little more of the lemonade and put it in there, no problem. What is difficult to do though is to remove solvent from an already concentrated solution or from a solution that's already been made. You'd have to boil off the solvent, and that's a pretty tough thing to do. When you're cooking, sometimes they'll tell you to reduce the sauce or reduce the liquid, and that's what this is. It's increasing the concentration or the molarity of the food flavor that's in it in order to make a more delicious sauce. But in general, we don't want to have to remove solvent from a chemical, mostly because heating it isn't always a really stable thing to do. So for our purposes, we will either be decreasing molarity by adding water or increasing molarity by adding solute. That's what's permissible to do in our general chem class, like the one that we're in. So there's a formula to help with this, and the formula is C1V1 equals C2V2. And so I just want to take a second and put that on the board so that you guys can have it to use. So C1V1 equals C2V2. And really what this is telling us is C stands for concentration. So this is concentration 1, and that could be in anything. That could be in parts per million or molality or molarity. And the only one we actually know is molarity. So we are always going to be measuring C1 and C2 in molarity. So you may want to call it M1V1 equals M2V2 if that helps you, where the M then would stand for molarity. Okay, that would be our molarity. And V, just like in all of the math that we've done for most of the semester, V is volume, and it can be in liters or milliliters. So we're going to use either C1V1 equals C2V2 or M1V1 equals M2V2, whichever one works better for your brain is fine. But either way, the volume can be either in liters or milliliters as long as we're consistent. And our concentration should be in molarity for our class because that's the only thing we've learned. Okay, so it's time to go ahead and start a problem. So this problem is about me, and it says that I need to prepare a 500 milliliters of 1 molar hydrochloric acid, but me, I only have 12 molar hydrochloric acid on hand. What volume of the concentrated acid do I use to prepare the new solution? So we start with our given and our find. I need to prepare, so that's like the second thing. I need to prepare a volume, V2, of 500 milliliters that has a concentration that's M2 or C2, 1 molar. Okay, so I want to make 1.0 molar of HCl. What I'm trying to find how much to put in, and the concentration that I have to begin with is 12 molar HCl. So these are my first values. Now, it might be confusing to you that I put the 2's first and then the 1's. It's because the problem happens to start with what my final concentration and volume should be. But in reality, it doesn't matter which one you call it. As long as the 500 goes with the 1 molar, that could be V1 and C1 or V2 and C2. It really doesn't matter. Our equation, C1 V1 equals C2 V2. And so then I just go ahead and plug into this. So concentration 1 is 12 molar times volume 1, that's what I'm trying to find, equals concentration 2. I want 1 molar times 500 milliliters. So now I just plug this into my calculator. It's as simple as doing 1 times 500, which hopefully you already know is 500. And then that number divided by 12, which is 41.67 milliliters of HCl. So what this means, and I just want to take a second to kind of draw this out for you, what it means, because it's going to play a role in the next one, is that what I'm doing here is I have a container. Okay, this is my stock solution. I have a container with 12 molar hydrochloric acid in it. And so what I'm going to do is I'm going to pour 41.67 milliliters of this 12 molar hydrochloric acid. It's going to go in here. And then I'm going to add water. I'm going to add water until my final mark here is 500 milliliters. And when I stir that up, this solution in here will be a 1 molar solution. So that's what we mean. That's what we're showing is I'm going to take this 12 molar and I'm going to put it in here, and then I'm going to fill it up with water. I'm going to dilute it. And once I've diluted it all the way up to a total volume of 500 milliliters, then my solution will be 500 milliliters of 1 molar HCl. Okay, that's what it is telling me. That's what it's showing me. Okay, so there's one more problem to do here. Okay, in this problem, we're starting, this one's a little bit different. So we have a chem student who accidentally pours 50 milliliters of 2 molar HCl into 200 milliliters of water. So let's start with V1 and C1. So my first volume, my C1, or my first concentration, which is C1, is 2.0 molars of, what is it, HCl. And my volume that goes with that is 50 milliliters. I'm supposed to be finding my new concentration, which is going to be C2. That's my find. And the big question here is, what is my volume 2? So I want you to think about this. He pours, there's already a container with 200 milliliters of water in it. And then another container pours in 50 milliliters. So what will be my total volume at the end of this? My total volume, once the 50 milliliters has been added to the 200 milliliters, will be 250 milliliters total. So that's the tricky part. That's the trick to this one that you're supposed to be watching out for. Now that we have that trick passed, this is all going to be really, really easy. C1V1 equals C2V2. That's the one we're going to use. And so we go ahead and plug into it. 2.0 molar times 50 milliliters equals C2 times 250 milliliters. We're expecting a small concentration now, right? Because we've added a whole bunch of water to it. So 2 times 50 is 100, and then divided by 250 is 0.4. So my C2 equals 0.4, and then we have to put the correct unit. It's still a concentration, its unit is molar. So that would be the answer to my second problem. All right, I'll see you guys tomorrow.